Welcome dear children. In today's lecture, we are going to understand the theorem of the property of angle bisector of a triangle. We will also prove the theorem in a simple and easy method. In order to understand the proof very clearly, we need to revise certain concepts. So the concept which I am going to revise in this video are corresponding angles, alternate angles and interior angles. Those whose concepts are very clear of these terms can just skip the video and go directly to the theorem. So I would recommend to watch the entire video so that the concepts of this topic is very strong. Now we'll understand some concepts before we go on with ahead with the syllabus. The first one is parallel lines and transversal. What are parallel lines? I have already explained. Parallel lines are lines which do not intersect. An example I have told you is the railway tracks. Okay, so it never meets at any point. It continuously moves parallel. So line L is parallel to line M. Now what is a transversal? A transversal is a line that intersects two parallel lines in two distinct points. Now we have these parallel lines and then we have a line which is intersecting the parallel lines at two points, not at one point, at 2 points. And this is known as a transversal. In the figure, line L, this line is parallel to line M. Okay, and T1 is a transversal. And T1 is intersecting line L at point A and line M at point B. So, what is parallel lines? Lines which do not intersect. And transversal is a line which intersects the parallel lines in two distinct points. Now let's take corresponding angles. Now we have understood what is a parallel line. We have understood what is a transversal. Now the various types of angles are formed when we are intersecting the transversal with the parallel lines. The first one is corresponding angles. Remember this part many of you might be knowing, so you can just skip it. But for others you can just revise because these concepts are very important. Otherwise, you'll feel confused. So, first of all, corresponding angles. What is corresponding angles? If the arms of the angles formed by the transversal are in the same direction. What are the arms? Actually, when an angle is formed, it is formed with the help of two arms. Okay, and one point where these two arms meet. So, when these angles, the arms of angles formed by the transversal are in the same direction. When you have two angles, their arms are in the same direction. If it is going towards the right, then right side. Both will be on the right side. If it's onto the left, and then onto the left. If it is below the parallel line, one is below, the other one will also be below. So we'll understand the various types of corresponding angles. But first understand what it means if the arms of the angles formed by the transversal are in the same direction and the same side of the transversal. Remember, there are two sides. This is a transversal. You have this side, right, one side, and the left side. Two sides are there. So when we take the one side, then you have this side, right side, and the other side will be left side. Okay. Well, some of the angles will be above the parallel lines on the right side. Some would be above the parallel lines on the left side. Some will be below the parallel lines on the right side. Some will be, that means below the parallel lines on the right side, and some will be below the parallel lines on the left side. So there are different types of corresponding angles. We will have a look at each one, the pairs of corresponding angles. The first one is the right side of the transversal above the parallel lines. So as I said, two sides, right side and left side. When you have it above the parallel lines on the right side, so this will take it as right and this will take it as left. So this is the right side and you have, this is the parallel line, one parallel line is here, other parallel line is here. When we have the angle formed above the parallel lines on the right side. Okay, so this is one pair. So first one is this, ABD. This is the parallel line and the angle is formed above it. Next one is M is a parallel line. Angle is formed here. From where will you, when you're reading the angle, we'll start from this point, okay? We'll say BEG. One angle is here and the other angle is ABD. Okay, ABD and BEG. These are the two corresponding angles on the right side and where above the parallel lines. Now we go on to the right side below the parallel lines. So this one we have taken above the parallel lines, and now we will take this one below the parallel lines. Okay, right side. We have not gone to the left side. Right side of the transversal below the parallel lines. So this is the parallel line and we are taking the angle below it. Here this is the angle here and below. Okay. So what is the name of the angle? We start from here. So remember, we start from the right hand side. Remember, always the angle name should come in the middle. Don't name it as BDE. Okay, you have to start from the right hand side. Angle is the center point and then you come till here, E. So what is the name of the angle? It is DBE. And the next one we are going to start from here and go downwards. It is the angles on the right side of the transversal inside the parallel lines. Which are they? DBE, DBE and GEB. Here you have GEB, DBE and GEB. Now we go to the next type, which is alternate angles. Now alternate angles are pairs of angles which are on the opposite side of the transversal. Interior angles, what we said, which is on the same side. But alternate angles will be on the opposite side of the transversal and the arms show opposite direction. Right now what we are having, the arms in the same direction. Like this we had, right? We had it like this. The arms were in the same direction. The arms were right side. Or it would be left side. Right? Arms were on the left side or on the right side. But in the case of alternate angles, if one angle is on the left side, the pair of it will be on the other side. So one arm will be on the right, the other pair would be on the other side, other angle of the pair. Okay. So alternate angles are of two types: interior alternate angles and exterior alternate angles. Interior alternate angles are angles at the inner side of the lines, inner side of the parallel lines. Okay. Parallel lines and here alternate side. Alternate angles. Okay, one will be this and the other one will be here, and here and here. That means inside the parallel lines. And the other one will be exterior angles at the outer side. So we will have it outside the parallel lines. Okay, we'll understand each of them. First one will take interior alternate angles. Which is the first one? The first one is this angle. CBE, okay, and BEG. Remember what is happening? This angle is on the left side, whereas this angle on the right side. The arrow is on the right side. And where is it? It's between opposite side of the transversal. One angle is here on the left side and the other angle is here. So how do we name it? Let's see the naming. So you are going to name the first one. The first one is this CBE, okay, and the other one is BEG, first pair, and the other pair is, so this is the first pair of alternate angle, the other pair is here. Now the second file will be, the second interior angle will be FEB. FEB and BEE. The interior alternate angles will be FEB and BBE. Okay, one is above the parallel line on the left hand side and one is below the parallel line on the right hand side. Once again, this is the second part, second pair of interior angles. One is, that is FEB, okay, and DBE. You've seen that it is a zigzag shape. Either this way or this way. Here, these are the alternate angles. So this is the pair of interior alternate angles. Alternate interior alternate angles, once again, CBE and BEG. Okay, one is above and one is below. Okay, one is at this corner and one is this side. Alternate, that means it is forming like this. One angle is here and the other angle is this side. Okay, then which is our other pair? Other pair is FEB and it should be DBE. Okay, DBE, it should be DBE. So these are the two pairs of interior alternate angles. Now we go to the exterior alternate angles. Now where is the exterior alternate angles? Remember the outside the parallel line. So one is here above the parallel line. So other one will be below the parallel line on the opposite side. Exterior, one is here and one will be here. Okay, next one is here above, outside on the right hand side, whereas the other will be below the parallel line and on the left side. So let's see the angles. The first angle is ABD and the other pair is FEH. Remember, it is exterior alternate angles. Then the other one is ABC, here left hand side above, and the other pair is GEH. GEH, that is right hand side below the parallel lines. So exterior alternate angles, you have two pairs. Next we learn the property of angle bisector of a triangle. Having understood what is bisector, we will find it very simple. What does the theorem say? The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Bisector of an angle. Now which is the angle? Now we have a triangle here, ABC. ABC is a triangle. Angle of a triangle divides the side opposite to the angle. Now this is the angle and this bisector is dividing it in the same ratio. Which ratio? AC upon CB. We have done that activity on page 8. It had proved the same thing. So here we have in triangle ABC, sec CE is a bisector of angle ACB. Therefore, AE upon AB is equal to AC upon CB. So once again, what is the theorem? What does the theorem say? Theorem is the bisector of an angle of a triangle. Bisector of an angle of a triangle divides the side opposite to the angle. This is the angle and this is the side opposite to it, just facing across it, in the ratio of the remaining sides. So this division AE upon EB the proportion will be the same ratio, that is AC upon CB. So this is the angle bisector theorem.
Now let's prove the property of angle bisector of a triangle. Now what is the given condition? In triangle ABC, bisector of angle C intersects seg AB in point E. So I'll draw a rough diagram. In triangle ABC, bisector of angle C. No, the figure is the other way around. In triangle ABC, A, B and C. C is on top. Bisector of angle C. This is angle C and there is a bisector. Intersects seg AB. This is AB. This is AB. Intersects AB in point E. So here you have C, a bisector of angle C intersecting AB at point E. We have to prove that AE upon EB, AE, this is this part upon this, the ratio of AE upon this part, this is EB, is equal to CA and upon CB. That means when you are dividing the ratio, the opposite sides where the bisector is dividing, that ratio is equal to the remaining side. So CA upon CB. Okay, in order to prove this, we are going to draw a line parallel to ray CE. Now, where is CE? C is here, passing through point B. So we have to draw a parallel line which is going to pass through B. Okay, and it meets, and we have to extend the C. Now this will extend it a little bit, and this AC I have to extend it so that it meets at a point which will name it as D. Okay, so the neat figure is here. This is the triangle, and you have the bisector here meeting at point E. Then you have the parallel line and the extended line which is meeting at point D. Okay, now let's start the proof. So now we have drawn the rough extension, this construction we have drawn, the parallel line and the extension here. Now if we will take the first part, okay, that is ray CE is parallel. Now ray CE is here, this red line is parallel to this red line DB. Okay, and what is the transversal? AD is a transversal. This line is a transversal. Okay, here you have taken a part of that triangle figure as it is. I have put it here, and then since you tend to get confused when reading the corresponding, so I have turned it around so that we know exactly where are the corresponding angles. Okay, so we have, what is the parallel lines? The parallel lines is EC and BD. We have it here, EC and BD. These are the red lines as the parallel lines, and then the straight line here, this one is a transversal which I have drawn here. Transversal is here. Now angle ACE is equal to angle CDB. Why is it equal? Because they are corresponding angles. So what was corresponding angles? Above the, many types we have learned, this is on the same side, both are on the same side, right, above the parallel line. So here we have the first angle, we have ACE, and the second corresponding angle is CDB. Okay, now we have found that these two angles are congruent. So we will mark it here. We will mark it in this. What is it? ACE. ACE. It's here. And the next one is CDB. So we have it here. CDB, we have it here. Okay. So we have found one, the first condition, first angle, we have found that they are equal. Now we take the same figure, but we are taking the same parallel line, that is C is parallel to DB. We have drawn the parallel line DB, right? But we are taking this transversal. Okay, the transversal CB. So when we are having the transversal, how does this figure look? This figure looks like this figure. A part of it I have taken and drawn it here. So this, what are these angles known as? In between the parallel lines, one, when you have it on the opposite sides of the transversal, those are known as alternate angles, right? Between the parallel lines, but on the opposite sides, on the different sides of the transversal, they are known as alternate angles. So which angles are alternate angles here? The alternate angles are CECB, this one, and CBD. CBD is here. Okay, here, where is it? Here it is ECB and CBD, this one here. Okay, so we have got a second pair of congruent angles. And now we go to the next pair. In the question it is given that this line, that's a CE, is a bisector. Now what is an angle bisector? It divides the angle into two equal halves, right? So what happens, which angles are equal now? Angle ACE is equal to ECB. This red line you can see here, this is one angle and this is the second angle. Why? Because this line, this ray CE is the bisector. So what does a bisector do? It divides the angle into two equal halves. So we have got a third pair of congruent angles, that is ACE congruent to ECB. Now let's see all of them together and draw a conclusion. The first one, we said that AC is congruent to CDB. Let's see all of them together and draw a conclusion. The first one, we found that angle ACE is equal to angle CDB. Angle ACE is equal to CDB. Why they are equal? Because we found that they are corresponding angles. Because we had taken AD as the transversal. The next we got ECB is congruent to CBD. ECB is congruent to CBD. CBD because they are alternate angles. Then we said ACE. ACE is equal to ECB, right? Because ray C is a bisector of angle ACE. Now we have got three conditions. Now let us compare it and see and draw the conclusion. Now we'll take angle AC as 1, angle CDB as 2, angle ECB as 3, and angle CBD as 4. Now ACE and AC is 1 and ECB is 3. Here we have ECB, this is 3. Okay, now let's take example to understand. Now let's take angle 1 is 30. Angle 1 is equal to angle 2, which is also assuming to be 30. Now in the third equation, angle 1 is equal to angle 3, right? So angle 3 will also be equal to 30. Now angle 3 is equal to angle 4 here. Angle 3 is equal to angle 4, which is also equal to 30. Now what can we draw from here now? That angle 2 will be equal to angle 4 because everything is 30, right? So angle 2 is equal to angle 4. Now which is angle 2? Angle 2 is CDB and angle 4 is CBD. So both the angles are equal. CBD is equal to CDB, right? With this example I have explained angle 1, 2. If you take as a measurement, then you will understand. Okay. Now we have found these two angles are equal. Now let's take the triangle. In this triangle, these two angles are equal. Which two angles we have found just now? We have found that CBD and CDB are congruent, right? We have found these two are congruent. Okay, when the base angles are congruent, the sides opposite to it will be congruent. So that means CB will be equal to CD. CB will be equal to CD. That's the next condition. This is the fourth statement. Okay, now in triangle ABD, EC is parallel to BD. We have drawn it, right? Construction, we have drawn it. So what happens when the sides are parallel? What happens to the sides which are intersected by the parallel lines? They are in proportion according to basic proportionality theorem. So AE upon EB is equal to AC upon CD, AC upon CD. Why? Because what does the basic proportionality theorem say? When one line parallel to one side of the triangle, if it intersects the other two sides, then those two sides are in proportion. So that is why we have got AE upon AB is equal to AC upon CD. Now we have found that CB is equal to CD, right? CB is equal to CD we have found, and in this equation what we found just now, AE upon EB is equal to AC upon CD, and in the previous we learned that CB is equal to CD. So instead of CD we can write CB because both are equal, right? Because they are equal, instead of CD we are going to replace it and write it as CB. We'll write it as CB. So the final equation will be AE upon EB is equal to AC upon CB. AE upon EB is equal to AC upon CB. This is what we wanted to prove. So what have we proved? That the bisector of an angle, bisector, which is a bisector, C is the bisector of the angle. It divides the side opposite, which divides the side opposite in the same ratio. So which ratio it is dividing? AE upon EB is equal to, which is the remaining sides, CA or AC. You can write it as CA or you can write it as AC, it means the same. And what is the remaining side? CB. So this is what is the property of angle bisector of a triangle. So we have found and we have explained the proof of the property of angle bisector of the triangle.